Hello everyone. In this video, I'll discuss about Woodward Fieser rules, a very important topic for GPAT 2026 from chemistry point of view. So let's dive into the topic. Woodward Fieser rules helps to predict the maximum wavelength of absorbance for conjugated systems like dienes, alpha, beta, unsaturated carbonyl compounds. So Woodward Fieser rules is given by two scientists named Woodward and Fieser. So they given some rules to predict the maximum absorbance of a wavelength of a compound conjugated dienes. Here, there are some rules. The first rule is homoannular diene, where it contains a conjugated double bonds in the same ring. So here you can see that whenever a conjugated double bond is present within a single ring, within a single cyclic ring, it is considered as an homoannular diene. And they given 253 nanometers for each homoannular diene. When the same conjugated diene is present or is shared between two cyclic rings, then it is considered as an heteroannular diene. And they given 250 nanometers for heteroannular diene. Here you can see that double bond, single bond, and double bond. This alternative double bonds is called as conjugated dienes. So when this conjugated dienes is shared between two rings, then we consider it as an heteroannular diene. Here also you can see that double bond, single bond, and double bond. So here the alternative double bonds are shared, or the conjugated dienes are shared within two rings. So that's why we consider this as an heteroannular diene, and they given 250 nanometers for heteroannular dienes. When the conjugated dienes are shared between a single ring, they consider as an homoannular diene, and they given 253 nanometers. And if a double bond is present inside a single ring, we consider as an endocyclic double bond, and there is no nanometers or no absorbance for endocyclic double bonds. When the double bond is present outside the ring, either it can be any point of the ring, then they consider as an exocyclic double bond, and they given 5 nanometers for exocyclic double bond. And a double bond exchanging conjugation, here you can see that double bond, single bond, double bond. So this is in general diene, so general conjugated diene. So when the double bond extension, so here this type of a series of these conjugations is called as an extending conjugation. Here you can say that double bond, single bond, double bond, this is a first conjugation. Again double bond, single bond, double bond, this is your second conjugation. So we shouldn't consider the first conjugation, we should only consider the second conjugation. So for each extra conjugation, they given 30 nanometers. And for alkyl substituents, so any alkyl substituent present in the ring which are involving in the conjugation, they given 5 nanometers, and for every ring residue they given 5 nanometers. So these are some rules given by Woodward Fieser. So we'll do some examples. Here you can say that double bond, single bond, and double bond. So this conjugated diene is shared within a cyclic ring. That's why we consider this as an homoannular diene with the 253 nanometers. Again, here you can see that there are two alkyl substituents attached to this conjugation, involving within this conjugation. So we consider only the alkyl substituents which are involving in the conjugation. So here we have two alkyl substituents. So for each alkyl substituent 5 nanometers. So 2 into 5 are 10 nanometers. Now for the point of ring residues, just draw a circle around this conjugation. So now consider how many bonds are attached within this conjugation circle, 1 and 2. So 2 bonds are involving in the circle. So the number of ring residues are 2. For each ring residue 5 nanometers, and for 2 ring residues 10 nanometers. Total 273 nanometers is the predicted maximum absorbance, predicted lambda max of this compound. So moving on to the second example, here you can see that this conjugated diene, double bond, single bond, and double bond. So this conjugated diene is shared between two rings. Let's consider this as ring A and ring B. So this conjugated diene is shared between two rings, double bond, single bond, double bond. So this is an heteroannular diene. So we are given 215 nanometers. So here you can see that there is one alkyl substituent, but this is not involving within this conjugation. That's why we are not considering this alkyl substituent. So here you can see that this is ring A and ring B. If you look at ring B, this double bond is an exocyclic double bond of ring B. Just remember, exocyclic double bond means any double bond outside the ring is called as exocyclic double bond, and they given 5 nanometers. So for ring B, this is an exocyclic double bond. So they given 5 nanometers. And if you check the ring residues, just draw the circle around this conjugation. So double bond. So 1, 2, 3. So there are 3 bonds attaching to this circle. So 1, 2, 3. So 15 nanometers. So total 235 nanometers is the predicted lambda max of this compound. Here you can see that double bond, single bond, double bond, again double bond, single bond, double bond, double bond, single bond, double bond. So this is an example of your extension conjugation. Consider one double bond, single bond, double bond. This is one first conjugation, double bond, single bond, double bond. Again double bond, single bond, double bond. Second conjugation, double bond, single bond, double bond. Third conjugation. So don't consider the first conjugation, just consider the next conjugations. So 2 and 3. So here we have 2 extended conjugations are there. So for each extended conjugation 30 nanometers. So for 2, 60 nanometers. Here we can see that, let's consider this as an ring A and ring B and ring C. So for ring A, this is an exocyclic double bond, and for ring B, this is an exocyclic double bond, and for ring C, this is an exocyclic double bond. So 1, 2, 3. So there are 3 exocyclic double bonds are present in this compound. So 3 into 5, 15 nanometers. And if you consider this ring residues, just draw a circle around this conjugation. So 1, 2, 3 and 4. So 4 bonds are touching this circle. So 4 into 5, 20 nanometers. And of course this is an heteroannular diene. So double bond, single bond, double bond. This conjugation is shared within the ring. In between 2 rings. Double bond, single bond, double bond. So when the conjugation is outside the ring, it is called as heteroannular diene. So it's 215 nanometers. Moving on to the next example. Here again you can see that double bond, single bond, double bond, double bond, single bond, double bond. So the conjugation is outside the ring. So this considered as an heteroannular diene having 215 nanometers. So if you consider ring A and ring B, so for ring B, this is one exocyclic double bond and this is second exocyclic double bond. So there are 2 exocyclic double bonds are present for ring B. So 2 into 5, 10 nanometers. And if you look at the ring residues, just draw the circle around this conjugation. So 1, 2 and 3. So total 3 bonds are touching with this ring. So 3 into 5, 15 nanometers. And if you consider here double bond, single bond, double bond, and double bond, single bond, double bond. So this is an extended conjugation. So double bond, single bond, double bond. This is your first conjugation. Again double bond, single bond, double bond. This is your second conjugation. So don't consider this first conjugation, just consider only second conjugation, extended conjugation. So 30 nanometers. So this is for this compound. And if you understand the concept above, just solve this question and drop the answer in the comment section. So I hope you understand everything. So very important topic for GPAT 2026. You can expect a guarantee question from this topic. And if you have any other topics to be discussed, just drop a message or drop a comment in the comment section. I will discuss or I will make videos on the next topics. So be consistent, revise every day. All the best. Thank you.